Last time on The Matrix Show, we talked about how you can take a collection of equations and dump them into a matrix. When you do, in place of the equal sign, we're going to write down a vertical line, and that makes the matrix something we call augmented. Well, people, the exact opposite principle is true. If you see an augmented matrix, that's basically a bunch of equations in disguise. And that's going to be helpful for allowing us to figure out what we're allowed to do to augmented matrices. Remember, our whole goal is to take a bunch of equations, put them into a matrix, and then do stuff to that matrix that would be easier than if we were working with the original equations. Now check it out. Let's say you've got two equations staring you in the face. If you want to write those equations down in the opposite order, that's totally okay. You haven't changed anything. And that means that when you have an augmented matrix, if you switch two of the rows, that's also okay, because secretly all you've done is switch the two equations. Here's another thing we're allowed to do. If you have a single equation, you can multiply the entire equation by, I don't know, 4. And that's okay as long as you do it on both sides of the equation. That means that whenever you see a row in an augmented matrix, you can multiply that row by a single number as long as you hit every single part of that row with the same number. So you're allowed to multiply rows by numbers. And guys, last but not least, when we were solving these systems of equations back in the day, we were allowed to add or subtract two equations. And in matrix land, that's the same thing as saying that we can add or subtract two rows. So we've got three allowable operations on matrices. We can switch two rows, we can multiply a row by a number, and we can add or subtract two rows.